Today I'm going to speak to you, and it's going to be an absolute pleasure talking about .NET and NAV Interop. Is there anybody here in this room who has never declared a .NET variable in CAL? Okay, plenty of you. So is there anybody who thinks they know everything about it? Like, okay, I do not, but I'm just encouraging you to. Like, okay. I hope to see a couple of hands up there because I'll need your help when I'm doing demos for you today. So the title of the presentation has changed because I was not initially scheduled to deliver this talk today. It was there should have been a guy from Microsoft. For some reason he has canceled, so I was asked if I could jump in. So I have changed the title from two mightiest development frameworks ever brought together into .NET Interop, the beauty and the beast meet. So who is the beauty and who is the beast? I leave it completely up to you. But as far as color coding goes, I think I've made up my mind. So what are we going to do in the next hour and a half? So we're going to do a deep dive into .NET and NAV Interop. So we're going to see how it works. There's going to be a lot of talk. I'm going to talk about everything. I hope so. I'm going to try to cover all of the topics that are relevant for you to be able to start coding and to be able to raise your hand high in the air next time when somebody asks you if you know everything about .NET Interop. And also we are going to walk the walk. We're going to do a lot of demos. I'm basically going to demonstrate every single concept that I talk about. I hope there will be enough time and I hope no demos break. So why is .NET interoperability important in NAV? Because no matter what anybody says and no matter what you think, CAL is a very, very, very limited language. So who disagrees with me that it's very limited? Okay, a couple of hands. Well, okay, I challenge you to talk to me after the presentation, but I think it's funny that I didn't see any Microsoft people or any MVPs raise their hands. So, okay, but it's just a matter of opinion. The reason why we need .NET interoperability is not primarily because CAL is a very limited language. It's because basically ERP is not an island anymore, and NAV is an ERP system. We need to connect it to many things. We need to deploy it in the cloud. We need to talk to other applications. We need to be able to extend it beyond what it was initially intended to be used for. Also, it is important because CAL is sometimes very clumsy to work with. There are serious limitations, especially as it relates to access, for example, to operating system, as it relates to access to, for example, the layer on top of which it resides, which is SQL Server. So .NET is a much simpler environment which allows you to do those things. Also, .NET allows you to choose your language. You don't have to write in a Pascal-style CAL language, which might be simple, might be difficult, no matter how you approach it. But in .NET, you can choose whether it's going to be Pascal, like, for example, in Delphi, or you can choose Visual Basic, or you can choose C# or any other language that you prefer. Also, deployment of .NET applications is very simple. It can be as simple as just copying a file from one folder to another. It can be a little bit more complex, of course, but it has a very strong security. So .NET will let you control security aspects of your application on such precise level as, for example, lines of code. So you're able to specify that a specific line of code, for example, or a function executes in a different security context, stuff like that. And also, .NET comes with a very rich API with a lot of libraries. We're just going to take a peek on some of them. But basically, there are hundreds, if not thousands, of Microsoft-provided or third-party provided libraries which are ready to use just out of the box. You just start using them immediately. So before we continue talking about any more theory, I'm just going to show you a very quick and short demo about how we can make .NET interoperability work. So first thing is, I'm going to basically create a code unit. Just going to save it as test code unit. I'm going to use this code unit throughout the day for all the demos I make. So I'm not going to be storing any of those demos. There is not going to be any download available to you, but you will have my email address. You can contact me through my email or my blog, and I can basically repeat all of these demos for you and help you with anything related to .NET interoperability. So first thing I'm going to do in this demo is basically make a framework to call this code unit from my RTC client. So I'm going to page customer list. I'm going to show the actions. I'm going to create an action. Do the demo. I'm going to add a nice image to it. I'm going to promote it to process group, and it's going to be promoted as big. And it's going to call my code unit. Okay. So if I go to my role-tailed client, in my customers list, I should be able to see a nice big button. There it is. So it does nothing at the moment, but we're going to do it something really cool. So back in my code unit designer, I'm going to declare a text constant, which is going to be called okay. So hello TechDays. I'm tweeting right from RTC. Isn't .NET Interop cool? I think it's a pretty cool text constant. And I'm going to declare a code unit. I've prepared it in advance because I don't want to share my Twitter username and password with you. It's not that I don't trust you, it's just that it's, they say security is important, and I'm talking about .NET, which is secure, so I should demonstrate it on every step. And finally, I'm going to instantiate a Twitter client. So what I'm using here is basically a Twitter client which I found on the internet. So it's not something that I've written. It's basically functionality that somebody else has developed and deployed as a .NET library which can be reused by any application, including NAV. So I'm going to use that application here. So I'm not going to talk about concepts right now at this stage. I'm going to talk about it later. So basically, I'm first going to log into my Twitter account. And then basically, I'm going to say if Twitter tweets, and I say text 001 000. I'm showing the error. Sorry. So as simple as that. I'm going to log into my Twitter account and see if there is anything there in my tweets. So I'm not tweeting much, so let's. Now, if I click do the demo, I will either get an error message, which did not happen, or I'm going to basically wait for a couple of seconds and see my tweet appear. So this was a small and nice thing that you can do with .NET Interop, but it's just one of the zillion of things and opportunities you have with .NET Interoperability. So I'm going to close this and delete this code unit. So if you need something like that, I can deliver this to you afterwards. So first thing we're going to do is a small overview of .NET framework. So what it is about. We're going to talk about common language infrastructure. We're going to talk about assemblies, about security, about class libraries, about memory management, and about the rich stack of functionality. I'm really going to spend only a couple of minutes of this. I'm going to focus later on practical stuff. So in the core of .NET is the common language infrastructure, which is a framework which enables simple development in any language and execution of that code in a machine native way. So it has several layers which translate the code from human understandable language into machine understandable executable language. It contains a layer which is responsible for memory management. We are going to talk a little bit about it. So we are going to mention a concept of managed code. So this is one of the prime responsibilities of common language infrastructure or common language runtime. In .NET, what we produce, we call them assemblies. So assemblies are basically DLL or executable files which contain executable code. And they are the building blocks of .NET functionality. So whenever we're using something that resides in an assembly. So we can deploy those assemblies in several ways. We're going to talk a little bit about deployment options. One thing about Microsoft provided functionality is that all of the .NET assemblies which are native to .NET Framework itself are accessible by default. So it means that when you write a .NET application or a .NET assembly, if you don't take extra steps, everybody will be able to consume that easily. About security, also I'm not going to talk too much. .NET allows you to have code access security, which means you can define in what security context your code executes. There are several possibilities. First of them, and the simplest, is to actually declare the whole library, or sorry, the whole assembly as requiring specific permissions, which can be, for example, administrators or highest available permissions. Or you can do that on a code level, so basically have functions which execute in a like elevated privileges context or something like that. .NET also includes functionality for cryptography, which allows you to actually encrypt the data which is being transferred easily. And also it allows you to do very simple impersonation. So basically to have your code which is executing as one user to basically impersonate another user, which is a very important concept when you're talking or basically stepping out of NAV. So when you're in NAV and when you're executing CAL code, it's always executing in the context of either the user who is running the classic client, if this is the classic context, or the user who is logged on to the RTC client, if this is NST or web services. So with .NET, you can actually make your code run under any other user very easily. A little bit about class library. So class library is a huge out-of-the-box API, which is available for immediate consumption by your code. There are two basic layers of .NET Framework class library, which is the base class library, which is the base system objects, the most common, the core of .NET. And then you have the framework class library, which is a lot of other libraries which have been added to .NET Framework over time. So example of a class from base class libraries, for example, string or integer 32-bit or something like that, like Boolean or let's say string builder or something. An example of a framework class library is, for example, link for XML or, for example, a regular expression. So this is the stuff which is not core to .NET but has been developed and provided to you as developers from Microsoft. One of the important concepts of .NET is memory management. So when we talk about .NET, we mostly talk about managed code. Managed code is such code in which you do not have to care about memory allocations and deallocations. This is something that normally, as CAL developers, you never have to care about anyway. But when developing in other languages, it's sometimes important to allocate the memory or deallocate the memory. So in .NET, mostly, the CLR or Common Language Runtime takes care of that. So it basically has a garbage collector which makes sure that whenever a variable is not referenced by a living instance anymore, it is automatically released from memory. So this is something that Common Language Runtime does automatically. It is important to understand that concept because there is one important thing in .NET, which is possibility to have unmanaged code or unmanaged objects, in which case you still do need to take care of deallocation yourself. again, as developers and as, let's say, consumers of .NET interoperability, you will never have to take care of that yourself. This is something that NAV does for you. However, you need to understand the concept, because sometimes by not following the rules, you can make your application unstable. If you do not, we're going to talk a little bit about this scope and garbage collector. So remember, garbage collector is a component of CLR which is taking care of memory for you. So it's automatically releasing memory when it is not used by any living instances anymore. And about rich stack of functionality, we can see how it has grown over time from first versions of .NET until the latest ones. So in every version we get a lot more functionality in the framework class library. So latest additions unfortunately are not available to us in CAL or interoperability, because interoperability works only with .NET 3.5 latest. It does not work with .NET 4. And also, even if it did work, there are many limitations which would not allow us to actually use any of these two on top. But there is basically a very rich stack of functionality. There is almost anything you can imagine doing with Windows or with SQL or with Windows environment that you could not normally do from NAV, and that now you can very easily. So this was a little bit about theory and background on .NET. Now we're going to see how it works in CAL. So now we're going to do a lot of demos. We're going to see how to declare a .NET variable, what it is about. We're going to talk about constructors, instances, and static objects. We're going to talk about types, how they map to NAV. We're going to talk about NAV scope and garbage collector and why it is important to understand that concept. We're going to talk about how to use arrays, how to use collections, how to use enumerators. We're going to talk about generics. Then we are going to talk about enums. And then we are going to talk about text. What can we do with text now that we could not before? And then we're going to talk about limitations. What are the things that we cannot do with .NET Framework? So, first .NET. I haven't seen many things, many hands in the air when you said like you never declared. So most of you already know a lot about .NET. This is a new type of variable in NAV 2009 R2, which allows you to actually connect to any available .NET class. So available means that it either has to be deployed in a global assembly cache, which is what Microsoft provided assemblies do. They are basically deployed in the global assembly cache, or they can be deployed directly in the add-ins folder of your NAV installation. There are 3 of them. One of them is classic, and this one is important for development. And then there are 2 more. One is in role-tailored client, and one is in service folder, which are used by either RTC or service. So a little bit about global assembly cache. It is a central repository of .NET classes in .NET. So if you want your class to be available to any consumer without knowing where physically it is stored on your disk, then you can deploy it in global assembly cache. It requires several steps like signing your assembly digitally and then deploying it using a global assembly cache tool. Or you can deploy it manually by copying the file into add-ins folder. If you want to develop with a .NET assembly, basically accessing it from your development environment, which is classic client, then it absolutely must be deployed in the classic add-ins folder. However, this is not enough. If you do not deploy it either or both into role-tailored client and service add-ins folder, then it will not be available. So if you're using it client-side, then it has to be in role-tailored client folder. If you're using it server-side, then it has to be in service folder. So we're going to talk a little bit about how to use it on client, how to use it on server. So let's talk about instances and constructors. In CAL, we normally don't have constructors. So you simply declare a code unit, or you simply declare a record or a record reference, and then it is immediately available to you. Okay, record reference has its own exceptions, but still, you don't need to explicitly construct it. The closest we have ever got to constructors in in CAL was using automation objects, where we had to use the reserved word create. We should actually create an automation object before we use it. So in .NET, we do not call create. We need to call a constructor. A constructor is a specific method in .NET which allows you to actually instantiate an object. So is there anybody who does not know much about object-oriented development? Or I probably do not need to explain these things then. Okay, so constructors can be overloaded, which means there can be many different instances of the same, many different ways to construct an instance of the same class using .NET, and all of those overloaders are available in CAL as well. So let me show how that works. So I'm going to create, and I'm going to declare an instance of a constructor, of a .NET variable. So I'm going to make it, for example, X document. So what I have available here is my dynamics NAV, which is all of the assemblies which have been deployed to my add-ins folder. And I have .NET tab, which contains all of the assemblies which have been deployed into global assembly cache. So here I'm now looking for system.xml.link. So when I say OK, then I can choose which class I'm going to connect to. So I'm saying it's an X document. So basically, here I can say that my X document variable is instantiated using a specific constructor. And there are 4 constructors available. So I have a constructor which takes no arguments. Then I have a constructor which takes an object array as an argument. This is something that you cannot use in .NET Interop. So you cannot pass an object array directly in the way you could do that with NAV. So it cannot be inline. You would have to first declare an array, then populate it, then pass it to the instructor. So then we have basically possibility to add a specific link for XML object, and then we have possibility to have that. Sorry, this is a specific link for XML object. This is that plus the array of objects. So what I'm going to do is just call the plain constructor. So I'm going to say that my X document equals to X document.X document. Now this might look a little bit confusing because I'm specifying it 3 times. Why indeed I need it 3 times? So how does this work? First, this is the instance of the variable. So this is my variable that I am going to use in my code. Second is basically referencing to the class that this instance represents. So the class is hiding behind this variable here. Constructor can be thought of as a static method, and the static method can be called without specifically instantiating. So this is why I can call this X document. So the reason why this X document is here for the 3rd time is because the actual constructor is called like that in .NET. In .NET, the constructor is always called the same way as a class name. So if I renamed this to XD, for example, then my statement would look like this. XD equals xd.x document. So this will now compile, and now I have constructed my instance of X document. So what I'm going to do here is basically, I would like to show how it works, but so it's not about constructors. I'm simply going to call a method. Okay. So I'm going to explain what I've done. So we are going to roll table client. So this is a different way to construct an instance. So basically I'm calling a static method which is returning an instance of the object. This is not technically a constructor, but it still constructs an instance. You can think of it as a specific type of a constructor. So if I go to customers and I click on do the demo, basically I get my XML printed on screen. So this is how we construct variables in .NET. And now a little bit of theory about static objects. In object-oriented development, you have objects which are instances of classes, which means you have a class which describes what you can do with an object. And then you have an instance which is an actual representation of that class. So before you can use a class, you have to instantiate it. This is an object then. There is another type of object which is called static objects, where you do not have to instantiate a class. Basically, there is only one instance of that class, and whatever you do that on that class instance. So there is no need to explicitly instantiate such a class. So the whole class can be declared as static, which means there will be only one instance altogether for that class. Or a class can be instantiated but allow you to call, for example, static members, like a static method. And why it is important in NAV and .NET interoperability is because static classes and static methods allow you to do something that was not possible ever before without like creating new tables in the system or like sharing some state with external tools like message queue or I don't know what, file system. It's basically to share a server-wide state. For example, when you declare a static .NET class, that class is the same instance of that class is accessible by any client that connects to it. There is a similar concept which is single instance code units. However, the difference is that a single instance code unit is a single instance per connection or per session. So it's for one user. You cannot have the same instance of a code unit available to 2 different or 3 different users. While with static class, whoever accesses that class accesses exactly the same instance. So first time you access it, .NET server, NAV server will basically establish one single instance of it and serve it to all of the callers. So let me demonstrate how that works. So here I'm going to basically do the demo, which will show XML. And if I, it's a wrong way to demonstrate it, so forget my last sentence. So I'm going to create a new project in Visual Studio. So I'm going to say new project. What I have here is a template which allows me easier management of .NET interoperability applications. So I'm going to call it static demo. So what this project type does for me is basically it allows me to directly deploy anything into add-ins folder. It restarts the services for me, so I don't have to care about deployment manually. So go to class, and I basically call it dynamic. Sorry, and I make one member which is called public string text. So, and I'm going to create a static class which has public string text. Okay? So, okay, this has to be declared as static, as this member has to be declared as static. The difference between the two is that every single instance, every single connection or every single session for each user will have its specific instance of class, basically every single call or every single scope, if you want, in NAV. While here, all of them will share the same instance. So let's see how that works. I'm going to build this. When I build this, it's going to automatically be deployed into my folders. Since my service has been restarted, I will have to restart my Rolltail client as well. So let me first go here, delete this demo, and instantiate two classes. So both of them are going to come from my static demo. And it's going to be, first is going to be dynamic, and the second one will be static. So here I'm going to say dynamic equals dynamic. So I'm constructing the first one. And then I'm basically the second one cannot be constructed because it is static, so there are no constructors. So I can simply directly call any members here. So here I'm going to do class dynamic dot text equals 1, 2, 3. Okay, and here I'm going to do class static first session. Okay, let me make it first session for both. And then I'm going to show a message which is going to show so basically I'm showing a message which shows content of both classes. So if I go to my role-tailored client and start this demo, I will see the text first session displayed 2 times. Nothing thrilling about it, probably. So if I click this, it says first session, static first session. So if I change this and do not assign the text values and then start a second session of my role-tailored client, and I click here, the first one is empty because I did not declare anything, and the second one is not empty because it is static, which means there is only one instance server-wide which contains any data that I've assigned to it, so it is accessible by all users. So this is a fantastic feature, but it's also very dangerous. So you can use it to implement some kind of server-wide state which will not require you to, for example, add new tables or something to share that state between the sessions. However, it exposes you to security risks. Like if you store user-specific information or some business-sensitive information into a static class, then any session will have access to the same instance. This is why it is very important to understand when to use static methods or classes and when not to use static methods or classes. Basically, developing with static classes is simple because you don't have to instantiate anything, you don't have to construct anything, you don't need to think about how it has to be done and what is the correct constructor or something. But it's also very dangerous if you are misusing it. So do not just declare something as static because it is simpler to develop. Declare it as static only if you want to depend on this functionality. So I apologize for this. Okay. We have seen several of .NET libraries. So I've accessed 2 of them which I had available. One was Twitter client. The second one was this static class that I have just developed. And we have also seen Link for XML, which was .NET Framework library. So there are many of libraries. If we go back to classic client and see the declaration of the .NET variable, and then take a look at what is available in .NET tab, there are plenty of libraries. So these libraries are provided by Microsoft. There is one important library which you need to know where it is. So it's called MSCOR lib or Microsoft Core library. So this is the core .NET library. It gives you access to the core types and classes of .NET Framework. So if I open it, you can see that it has classes for accessing, for example, registry, but it also has classes, for example, for arrays, or classes, for example, like Boolean or string or whatever. So every basic .NET type is declared in MS Core library. Important thing to know about MS Core library assembly is that it contains types which are automatically converted to CAL back and forth. So some of them are, some of them are not. We're going to see detailed overview of what is converted and what is not converted and how does this conversion work. It's important to know that those types cannot be instantiated. So .NET Interop automatically limits that. So it's a feature of .NET Interop, not of .NET. So it's a feature of NAV, if you want, which basically limits your use of those types. So basically, in CAL, you cannot use a native .NET string because it is automatically converted to text variable in CL. Or you cannot use like int 16 or int 64 natively. It is automatically converted to like integer or a big integer in CAL. You cannot use, for example, decimal because it's going to be automatically converted to decimal, etc. And also, if you declare any variables of that type, they are going to be useless. You cannot assign to them, you cannot construct them, you cannot use anything. So you cannot call any methods on them. So they are there basically exposed, so you can see they exist, but you cannot use them. There are plenty of others in this MS core library which can be used. So we're going to see which ones are out of reach. And then there is one funny thing about .NET Interop. It is intended to be generic, so that basically you can access any generic type of .NET. But unfortunately, in fact, it is not totally generic. So a lot of implementations of .NET stuff are very specific, especially in MS core library. So a lot of classes here are specifically implemented. So they do not use actual .NET functionality. So this is also important to know. If something does not behave as expected in MS core lib, it is expected. So it's not probably intended to be that way, but it's a side effect of the fact that CAL tries to map things to .NET automatically. So let's talk about data type mapping. In CAL, you have basic types like integer, boolean, text, code, option, etc. So those types are intrinsic, which means they are a part of the language framework itself. In .NET, there are not many things such as intrinsic types. So basically everything is a type in .NET. So it may have a language shorthand, like instead of using string with capital S in C#, you're going to use string with lowercase s, which is going to be like a keyword. It is just a shorthand or shortcut to the class itself. The same is with boolean or integer. So this is how .NET works. CAL maps directly to certain types. There are two types of mapping. One is bidirectional mapping, when you can convert from CAL to .NET and back without losing any information or without risking any information loss or error messages. And there are unidirectional mappings where you cannot do that, where you can convert one way, but conversion in the other way is not guaranteed to work or may result in data loss or may result in an error. So we're going to see how that works. So for most simple CAL types, there is bidirectional data mapping, which works both ways. For some .NET types, there is no bidirectional, and also for some CAL types, there is no bidirectional mapping. So stuff that maps directly is this. So on the left-hand side, you have NAV types. On the right-hand side, you have .NET types. So character in .NET maps in NAV maps directly to system.byte in .NET. Integer maps directly to int32. So every integer is by default 32-bit in NAV and in .NET. Big integer maps directly to int64. Decimal, this is important, maps to double, not to decimal. So decimal is not decimal. Decimal is double in .NET. Boolean in NAV is the same as bool in .NET. Datetime maps directly to datetime. There is some, basically it shouldn't have been on this slide, because there are some limitations in variables you can assign in CAL as opposed to what you can assign in .NET, which doesn't make much sense, but still they're there. And also GUID is something that maps directly, so you can exchange GUID both ways. Now these are the things which are unidirectional from NAV to .NET. So this is guaranteed to work. You can translate CAL variables or assign them to .NET variables, but going the other way around does not guarantee you that you will get the same results. So option in NAV always maps to int32 in .NET. And options are basically just treated as integers in the SQL database. They're treated as integers in .NET. So since they are luckily zero-based in NAV, and since everything is zero-based in .NET, there is a possibility of one-on-one mapping between the two. Then the text variable, it maps directly to system.string. And we're going to talk about text. So there is no bidirectional mapping. So sometimes you will not be able to assign data from .NET to CAL. So there is one limitation with text variables in CAL. One major limitation. Who can tell me what it is? Length. So it's 1024 bytes at most. .NET doesn't have that limitation. So you can assign any NAV string text to any .NET string variable, but if .NET string is longer than 1024, you cannot assign it back. So this is something that you need to think of when coding. Also, date and time. They exist in NAV, they do not exist in .NET. So .NET has only date time. So there may be some errors or data losses depending on what you do on .NET side with those variables. So they map to date time, both of them. Then duration. Duration cannot be mapped directly from .NET back to NAV because duration precision in NAV is nanoseconds and in .NET is nanoseconds and in NAV it's milliseconds. Then we have in-stream and out-stream. They can be, for most part, assigned directly. There are certain situations when streams will not be assignable directly from .NET. But I wasn't too sure whether to put them on this slide or the other. Because if you ask me which ones are most compatible, and Microsoft has done a tremendous job here to actually make in-stream and out-stream compatible, is the streams. You can do a lot of things with streams. We're going to see how it works. And then something that works the opposite way, like you can assign a .NET variable to a NAV variable, but if you try to going from NAV to .NET, you are going to either get an error or you're going to get a type mismatch or like unexpected results. For example, system S byte, the B should have been capital, I don't know why it's like this. So it's a short byte. It's basically just 1 byte of information. So it maps to integer in CAL, and integer is 4 bytes. So if you do something in NAV that exceeds the capacity of 1 byte, like assign a value of 500 to a byte and try to assign it back, you will get an error. And that will happen with any kind of variable that is listed here. So it's byte, it's system.char. It's also mapped to integer, while it's only 1 byte of information in .NET. Then it's 16-bit integer in .NET, and it's about any unsigned types. So in .NET you have unsigned possibility, which means the precision, for example, for integer, does not start at -127, for byte. It starts with 0, and it can go up to 256 instead of 128. We're going to talk a little bit more about signed versus unsigned. And then single and decimal. They both map to decimal in NAV, but they have different precision. So if you do something in NAV, try to assign back, you will probably get a type mismatch because it will try to convert to decimal, to double instead of those two types. Or you can lose precision or something. And then we have system.enum, which is enumeration, which allows you to actually specify multiple, let's say, semantic elements to basically to an integer variable. So you can always assign an integer variable to an enum, but you cannot, enum to integer, but going backwards does not guarantee to work or even may result in an error. So what to think of when using those data types? So NAV will always try to do the best when assigning them. So if you have a text variable in NAV and you assign it or pass it on to a .NET object which expects a string variable, the conversion is going to be done automatically. So it will always try to do the best. If it can, it will work. If it cannot, it will fail or it will behave incorrectly. So even though NAV thinks for you about how to convert those things, you still have to be the guy who is in charge of that, in charge of data conversion. You need to be in charge of how the data is handled in either of the environments to ensure that if you pass a unidirectionally assignable type from one environment to another, that you are not breaking those limits. So with integers, you primarily need to be concerned about whether they are signed or unsigned. So if it is signed, it means it goes into minus something up to plus something, and 0 is usually in the middle. So if it is unsigned, then it starts at 0 and goes to maximum capacity. For example, 1 byte or 1 byte of information, if it is signed, it's minus 127 up to 128. If it is unsigned, it's 0 to 256. Or if it is integer, like 4 bytes, then it can be minus 2 billion up to plus 2 billion. If it is unsigned, then it's 0 up to 4 billion something. So NAV does not have such concept. So to be safe, do not use unsigned types. Signed types. That's to be safe. However, if you are using a .NET functionality, which unfortunately is out of your reach, which does depend on signed types, unsigned, then you will need to care in CAL code that you do not try to assign an out-of-range value, because CAL code will compile, it will let you do things, it will try to execute, and then you will fail on CLR level because you try to assign something that is unassignable. About strings. Strings are funny because there is another limitation in CAL about strings. First is it is length. What is the second limitation? Code page. Yeah. So you have available only one code page at a time, or not at a time, at the duration or lifespan of your database. So you can only have one code page. In .NET, strings are Unicode. And funny thing is, we are going to talk a little bit about strings. .NET will eliminate those limitations for CAL as well. So let's actually move on. Let's talk a little bit about CAL scope and garbage collector. This is going to be a little bit more of theory, not much practice. And then we are going to talk a little bit about how to use explicit types, including strings and texts. So in .NET, as we said, garbage collector is in charge of releasing any memory that is used. So if you assign or instantiate an object and assign it to a local variable, when that local variable goes out of scope and there are no more instances linking to that variable, to that instance, then the instance is released from the memory, automatically by the garbage collector. Not necessarily at the moment it goes out of scope. It can be like for hours in memory, depending on what CLR is doing. But it is guaranteed to basically get released when memory is needed. So in .NET, if you have an instance, which is, for example, let's think of a string. No, string is a bad example. Let's think about XML document. So you have an XML document, which is a local variable. You instantiate it locally. You fill it locally. And then you assign it to a global variable or some variable which is out of scope of the local function. When the local function completes, the local instance would get released because the variable goes out of scope. But garbage collector detects that there is another variable linking to the same instance because you have assigned the instance, basically a pointer to the instance, to another variable. So garbage collector does not do anything, it keeps it alive until that other variable also goes out of scope or gets released manually. So this is how .NET works. In NAV, it is not exactly like that because there are also unmanaged code, which is the code which accesses resources which are not managed or not under control of common language runtime. And to declare an object to basically use any unmanaged resources, it has to implement the iDisposable interface, which will then tell to common language runtime that it is either disposed manually or that it has a different disposable pattern. And on those objects, you can call, and you should call, dispose method manually to release those resources. And funny thing about .NET Interop in NAV is that everything in NAV is basically it also implements the iDisposable interface, which means every .NET Interop variable, even though it itself, the variable that you're connecting to, would not require you to call dispose or would be, let's say, managed, .NET Framework interoperability NAV layer basically makes it unmanaged. So whenever a variable goes out of scope in .NET Interop, CLR is not doing anything about it. It's the .NET Framework interoperability layer of NAV which manually calls dispose method on every local variable. Which means that if you have a local instance which you assign to an instance which is out of scope of local function, like a global variable, then dispose will be called on an instance and it may get disposed. It is not guaranteed to be disposed, though. It completely depends on what CLR is going to do about it. So an instance may stay alive. You can even be able to see it alive from global scope, but it's not safe to use it because it's basically going to die sooner or later, and your code will break because it will depend on an instance which is not alive anymore. So do not ever declare a local variable of .NET type and assign it directly to a global variable, because this is guaranteed to fail at one point. Okay? So I'm not going to show that directly, but you're going to see how you can verify those claims. Let's talk about arrays. So arrays are very similar to CL arrays. They allow you to store objects under the same, let's say, variable. So you can have a collection of objects of the same type. They're not exactly the same because, again, in CL you have a lot of limitations. Like you can have maximum, I don't know how many, 10,000 elements, or what's the total number? There's a total number of elements you can have in an array. There's also maximum of 20 dimensions that you can have in an array. So there are those limitations that CL has, that .NET does not have. So a .NET array is not exactly equal. So characteristics of .NET arrays are that they are strongly typed as anything in .NET, which means that an array has to be of a specific type. This is exactly the same as in CL. And also they are fixed. Again, something that is true of NAV or CL arrays as well. So in those two respects, arrays behave the same way. However, arrays have to be instantiated in .NET, and there are certain methods that you can call on array instances. So you cannot index on them using those square brackets. You have to actually call methods like set value or get value, or if you want to access the length, you cannot use like methods that you would normally use in .NET. In CL. So let's see how we can work with arrays. So I'm going to delete all of this. I don't need it anymore. I'm going to create an array, and it's going to be a .NET array. So arrays are a part of core library, so I can access them here. So first thing I need to do with an array is to create an instance. So I would normally do it using a constructor. However, array does not have a constructor. So it's basically, it's not a static method. It's just that you cannot construct it directly. So to construct an array or instantiate it, you have to call create instance method. And funny thing is that for create instance, you have to specify of which type this array will be, and also you have to specify how big it's going to be. So what is the size of this array? So you cannot call this element type directly for intrinsic types. So if you want to create an array of, for example, text or string, you cannot do it just by using the .NET framework functionality available in the interop itself. You have to do a piece of code. So let me go back to my class. I'm going to close my role-tailored clients. I'm going to save this as uncompiled, and I'm basically going to create sorry, I'm typing in the wrong place. I'm just going to edit here, public static type string type. So this is the way how I can return a type of a variable back from .NET to CL. So if I want to have an array of string, then I have to call the type of string, which is something that is completely inaccessible, no matter what you do from .NET Interop. Simply because whatever you do with string in .NET, first thing that CL will try to do is map it directly to text, and then no methods that are available in string type or class in .NET will be ever available in CL. So the only way to pass the type of string or type of any intrinsic CL object which maps directly to .NET is to actually create a wrapper. For example, public static type int32 type of, and you imagine it's int32. Okay. So I'll build this now, and I'm going back to my classic client. So at this stage, I can actually instantiate this array. So I'm going to declare one more variable here, which is going to be like dn.net, and I'm going to map it to my static demo. And it's going to be, I think I declare it in dynamic class, yeah? So dynamic. So if I want to instantiate this array, I would call create instance, and then first argument is element type, second is length. So I say that as type, I'm actually calling the string type, and I'm calling 5, which means I will have 5 elements in this array. So at this stage, I cannot do something like this. So this will not compile. So array is not a NAV array. We can make it a NAV array, but this would just make it completely useless. So let's see what we need to do. So if we want to assign a value, then we need to call setValue method, which accepts 2 parameters. First is the object instance, so what is the value that we're assigning, like first, and second is position on which we are assigning, which is 0-based, different from how CAL treats arrays. So it's 0, and then I'm going to set value second, and I'm going to put it on second position. And then I can do it like or I can actually say array.length. And then I say which value I'm taking from, which is again the index. So instead of that indexer in square brackets, I actually have to call this get value. Yeah, absolutely. Thanks. So if I go back to my CL to roll-tailor client, I will see how it works. So when I click this, I'm going to have first and second and then 3 which are not empty. They are nulls. Because a string in .NET can actually be a null, which means it's not empty, it has no length, there is no instance behind it. So this is something that .NET brings into CL as well. So strings in CL are nullable, or text variables would be nullable. You cannot do like assigning null directly in CL, but again, .NET can make them nullable for you. This is one of the side effects. Okay. So I've called it too many times because I should have mentioned like -1, which length is 5, but the highest index is 4. So right now it would work with no errors. Okay. So this is about arrays. Then let's talk about collections. They're similar to arrays, they're just different. So collections are also used to store multiple objects of the same type. However, the difference is that they allow better manipulation options, like have many more methods you can use to manipulate elements. And they are not fixed, they are dynamically sized. You can limit them though. You can say like I want a collection of string which is 5. Of size of 5, it cannot accept more, but still, if you do not declare maximum capacity, then it will just be unlimited. You will be able to store no matter how many you wish elements in a collection. They are again strongly typed and they are dynamically sized, which means the .NET takes care of that itself. You don't have to think of it how to actually limit the size. So the only thing you need to care about is the ultimate indexer, so how many objects you have in a collection. So instead of set value and get value, we have different methods that we call. So we call add We do not assign to an element because when you instantiate a collection, it is empty by default. So it has 0 elements. You cannot assign anything to any element. So you have to add, or you can insert, or you can remove an instance, or you can remove at an index. And to access an element in a collection, you call item. Again, you do not use square brackets. And also, instead of length here, you have count, which is a method which returns the number of elements in the array, which is, again, an example of how nav.NET Interop is actually taking one more step over the .NET framework, because it turns a method into a property, which is telling me that some aspects of trying to make interop generic have actually resulted in some hard-coded things being very specific. For example, converting certain types, certain members from methods into properties. Okay, let's see how to use collections. So instead of my array of type string, I'm actually going to create a collection. So I'm going to create a string list, and it's going to be here in MS Core library. So it's collection, and then I'm going to use an iList. The problem here is, sorry, not iList, it's list. The problem here is that for the list itself, and that's something that we're going to talk about when we talk about generics, we again cannot instantiate a list of a specific type directly. We would have to instantiate it from outside of nav. So right now, this collection would take any object. So I'm still going to use it, but we're going to talk about generics a little bit more. So I do not need arrays anymore. I will delete these. And I'm going to say my string list is, now I create a list. So it has a constructor. So I directly call it. And then I say string list. Sorry, it has an n, which should not be there. As if it matters for anything, I'm not selling this code to anybody. So first, second, third. Okay, and then we have to call the item member of the list. So if I go to do the demo, have first, second, and third, and nothing more. And I can call other methods like string list.remove second, first, third. So I can say exactly which instance I want removed. Or I can say remove at second position, which is 0 base, so it will remove the third one. So lists allow you to have a more flexible manipulation of arrays or lists of the same object type. So then the next topic is generics. And lists and generics are very tightly related. So generics in .NET allow you to actually simplify development. So they are not there to make consumption of a class, especially not from .NET Interop, any easier. It actually makes it very difficult. The thing is that generics allow you to simplify coding in .NET itself. So for example, let's think like 12 years ago, I think it was .NET 2.0 which introduced the lists. So in .NET 1.0, when you wanted to have a list of integers, you have to have a specific class which is called list of integer, which would accept methods which handle integers like add and then integer as an argument. And if you want to have a list of strings, you would have to have a list which has method add, which accepts a string as an argument. So if you have like 50 different types you want to support, you will have to write manually 50 different classes with all the same methods and everything. So there come generics. So instead of having 50 different classes which do exactly the same thing on different object types, you actually have only one class which does it on a generic object type, which means at the compile time, it is not important to know which type it will be. However, at runtime, The exact type of the list will be determined by the argument which is passed to a generic. So let's see how it looks in .NET. So here, I have list of type string. Sorry. is constructed as a list of type string. And if I have list of type integer, is list of type integer. So when I say list.add, it accepts string as an argument, you see? And if I say listInt.add, it accepts integer as an argument. So in the runtime, it will be evaluated when you construct that. Basically, during compile time, based on that, the compiler itself will construct the instance of a specific type. So you can actually say list of dynamic and then add my dynamic class. So it can be used on any type, even on the type that do not exist yet. So this is a power of generics. However, if you want to use generics from .NET Interop, you cannot instantiate them directly. So any generic is instantiated directly as a type object. So if you want to create a list, for example, then it will be this. So it will accept object. And object in .NET can be thought of as a placeholder for just about anything, because you can, it's called boxing, you can box any kind of variable directly into .NET object without thinking of typecasting. So it's basically wrapped in an object and treated in a generic way. So this is what .NET Interop does with any list which is not passed on from outside. So if I create this list in CL, like string list equals string list.list, this is not a list of type string, this is list of type object. So I can actually say 15, or I can say this, or I can say this, and when I run this, I can see that anything can be stored in that list. So if I want to have a specific list of type string, then I have to pass that from my .NET library. So if I want to have a string list which accepts only strings, then I have to pass it like so. Right now I have a method which returns a new string list. I'm going to make it static. So let us now see how it works. I'm deploying this. So I'm simply going to change the type here. I'm going to, instead of saying string list equals string list.list, I'm going to declare a new variable, which is called dynamic, which is going to be my object, static demo dynamic. And here I'm basically calling list string, which returns my string list. And this will still compile. However, this should fail at runtime because I'm trying to stuff an object into a list which is type of string. So at compile time, compiler in CAL thinks it's going to be an object because it does not know exactly what kind of list is going to be returned. It knows, but it cannot do anything because whenever I declare a type of a generic instance, it is always treated by compiler as being an object. So if I click on do the demo, I get this because I'm trying to stuff an incorrect data type into a list of a specific type. So if you need specific lists, you have to pass them from your own assemblies, and then you have to be type aware. If you are happy with just having objects, then you can keep it as is. Okay. Let's move on. Let's talk about enumerators. So enumerators allow you to go through all of the elements of an array or of a list. It's very simple in a .NET to use an enumerator. So the only thing you need to do is, for example, if we have a list of dynamic objects, then we can say for each dynamic D in list D, do something. So this for each construct does not exist in CAL. So you cannot do for each. You have to do like for, and then start with 0 and go to length -1, or count -1, depending is it array or a list. However, you can also use an enumerator directly in CAL. So I'm not going to show that because we are really short on time, and there are a couple of things I would like to show before we close the theory. So enumerators are basically comprised of two interfaces. First is IEnumerable, which tells the CLR that something can be enumerated upon, so that you can use for each. And the second is IEnumerator, which is the actual interface which contains methods for iterating through elements of an array or an instance. So basically, if I would want to use it here, I would declare an IEnumerator and assign the getEnumerator result of my array instance or list instance, and then simply do while do this. So I'm not doing this because it's going to take too much time, but this is basically a for each in .NET in CAL. So you can still do that. The only thing is you need to declare an IEnumerator interface variable. And there is one caveat here. It does not work in all situations. So there are classes in .NET which will not allow you to do that. For example, link for XML. It uses a different type of enumerator which for some reason .NET Interop does not understand well. So again, this is not too generic in that respect. So use this only on arrays or generics of type list. It will work always. If it is any other kind of IEnumerable instance, for example, like nodes member of X document, it will not work, or it is not guaranteed to work. So use enumerators in this way, like while enumerated, move next, only if you have arrays or .NET instances. Or list instances. Then we have enumerations. This is not the same. Enumerations is the way to assign a specific semantic values to integers. So, for example, like options in NAV. Like you have an option in sales line table which says type. So is it an item or a general ledger account or a resource or like an empty option which stands for standard text. So this is basically something like enumeration in CAL. In .NET you have a specific type which is called enum. So you can say like and then you can say like empty, and then you can say like item, GL, resource, charge. There is fixed asset or whatnot. But this is a way how to use it. And this enum is always cast to an integer 32-bit. So you can assign specific values like empty is 0, item is 1, GL is 2. Or you can just leave it. If you do it like this, then it always starts at 0 and always ends at maximum -1. So for enumerations, I really will now direct you to go to Waldo's blog. I think you should all be familiar with Waldo's blog. If you're not, there's going to be a link. Waldo does a great job at making enumerations available in CAL in very, very nice way. Basically, by calling the enum.parse method of a system enum, it allows you to a very simple assignment of enumeration values in CAL. Normally, you would only be able to call it like enum equals integer, like 1, 2, 3, and then you have to think what is 1, what is 2, what is 3, or even if 3 exists in that enum. However, with Waldo's trick, you can actually pass a string name of the enum and have it assign a correct value. However, there is a little caveat there, which I don't know if Waldo is here, but it does not work. Yeah, okay, hi Waldo. So it does not work if you have an instance of an enumeration available directly as a .NET variable. In that case, you would first have to assign any value to it, like 0 or whichever. which is a trick because it may not have that specific value available. So it is not foolproof. It will work only for enumerations which are available as the members of an instantiated class. Otherwise, it will unfortunately not work. It will give you an error telling you that you first have to instantiate it. So, but this is something we can discuss later on. So let's talk about something that's really important, and then we will have to close. So text. In .NET, text are unlimited length, and they are Unicode. So guess what? In CAL, they are as well. So let's see how it works. So I'm going to make a public string hello world. And then I'm basically going to return so let me do a little trick here and say like hello world and translate it to, for example, Armenian. And translate it to, for example, Georgian. And translate it, for example, Gujarati. Or Arabic. So, okay. So let's try to see how it works now in CL. So I'm first going to deploy this. So message, and then I have dynamic hello world. So I will go to customers and guess what? Oh, sorry. There you go. So your NAV can actually handle or manipulate the Unicode strings. However, you still have limitations if you try to store that into a database, because then it will get converted according to your code page rules and it will not work. So for any in-memory manipulation of strings, there are no limitations. You can actually make it even smarter or stupider, whichever way you want, by doing something like this. String result equals oh, 10,000 is a lot, so let's just make it 1,000 of these, and then result. So a very long Unicode string. So, and if I run my so it's a very long Unicode string, like 10,000s of characters or something. So there are no limitations in string. Again, do not try to assign that to a CAL instance of a text variable, because then you still have the limitations of 1024, which hopefully will go away in one of the future versions. I do not know if, but I hope so. Okay, and then let's talk a little bit about some tips and tricks. So to handle really long strings in NAV natively, you could use big text, which would allow you to store as much as, I think, 2 gigabytes of text in one variable. However, the manipulation of big text was clumsy, because you could not assign it like to a message box, like to show the contents of a big text. You have to call get substring or subtext, it's called method of big text, which again is not resulting in a string. It assigns the content to a variable, so it cannot be used inline. So for those situations where you're dependent on big text, you can now depend on string builder, which is very similar to big text. It can store as much information as you can and has a lot of methods which you can use to manipulate. Unfortunately, I cannot demonstrate it because we don't have time. What I would, and also I'm not going to demonstrate regular expression, which is another thing you can do with strings now in .NET, which you could not, in NAV, which you could not earlier. So what I'm going to talk about, and this is the last thing, and I think I have just enough time to do that, and I'm probably going to steal 5 minutes of your coffee break, just to talk about streams. So streams are directly assignable between NAV and .NET. So let me show you a simple demo of how to use streams. So unfortunately, I don't think that I will have time enough, but if somebody is interested, I invite you to really come in the break and I can demonstrate it. So basically what I would do, and I'm really sorry, totally sorry I cannot show it right now, and it depends on you if you want to see that, is how to read, let's say, an XML feed from a blog. It would have been my blog, or it can be Mark's blog, whichever blog it is. So read the feed and store the data in NAV directly using just 2 simple concepts. An XML port and a .NET, a single .NET variable of type X document, nothing else. So it's basically 2 lines of code which read the data from an XML source on the internet and store it directly in a NAV database without doing much coding. However, I would have to do some tricks in .NET. I would have to eliminate unneeded items from the XML itself. But it's one of the things that you can do with streams. You can assign them directly to an in-stream or out-stream, or even not assign them to a stream. You can assign them as a source directly to an XML port, and it works directly without any tricks. So this is one of the very, very strong points of .NET interoperability, which I really like. So this is something that, if there is one thing that was done perfectly, it's streams. It's really handled fantastically. Okay, a little bit about limitations. So I will really have to close this now. So in comparison, or in comparing 2 variables, you cannot compare them directly because .NET variables are instance variables. So if you have 2 instances of a list, you cannot say if list equals other list, because instances will not be equal. So it may not result in a result that you are interested in. Another thing is events. Unfortunately, there is no way to make events work in NAV, simply because you cannot have delegates, because you would have to pass pointers to methods, which is something that, as of latest release, is not possible. So you cannot pass a pointer to a CAL function to a .NET, so it's incompatible still. Then there are certain CL syntax limitations which allow disallow concept like anonymous methods, or like lambda expressions, or like link, which is a very nice thing in .NET. You can use link on objects, like make from item in string list, select something based on certain criteria, simply making a query on a collection. So CL does not allow that, and there is no way to make it work, like predicate, stuff like that will not work. Then base class library is very inconsistent with static methods. So if you have a static class or a static method of an instantiable class, it will not work as expected if it is part of MS core library. Because obviously, and I cannot guarantee that's what probably somebody from Microsoft, if they have delivered this presentation, could tell you, but I imagine that some hard-coded calls have been made in .NET Interop at that point. So this is why certain static methods will not be callable. For example, get type of type, which is not directly mappable to any type in the vision, but that type still will not allow you to call static methods of an instantiable class. And then 2 big limitations is that .NET 3.5 is the latest version, and then it only works in NST or RTC. It does not work in Classic. And you can debug it. So this would be also a nice thing to show, and I think I have just enough time to do that. So I'm basically going to set a breakpoint here, and I'm going to say build and debug and attach that to Microsoft Dynamics NAV server. I think this is the server. Yeah. So I've attached my debugger. And I click do the demo, and here we go. So we have a breakpoint in our own code in .NET just by attaching a debugger to a running instance of a server. Of course, you have to start it with enable debugging set to true, but then you have to deploy a debuggable version of your assembly together with the PDB file, and then you can debug into your own code, which is a fantastic thing. And funny thing is here, if we simply, sorry, I'll just close it. If we step through this, okay, I will move to this point and then step out. I get into my NAV code, basically C# code of my code unit 50001. So it makes debugging very, very simple. So you don't have to even think of where the classes are. It's simply available out of the box. Okay. Another thing I cannot show to you, but again, I'm going to direct you to Waldo's blog, is how to call NAV web services. So basically, also on my blog, there is a session that I delivered for Microsoft a couple of months ago, which basically for partners through Microsoft, which has a nice demo how to call intercompany postings directly, like create a document in another NAV instance and post it from, like in a transactional level, from one database to another. So your imagination is the limit of what you can do with .NET Interop. So for deployment, I'm not going to talk about much. I've mentioned all of these things already. So you have an option of global assembly cache, or you have an option to deploy it in add-ins folder, in which case you have to deploy it in all, like server, service, classic client, and roll table client. So that's it. Here are a couple of resources. I think slides will be available. If they're not, there is my address on top of this. Just drop me a note. I'm going to hint you where to go. But I believe since you are Mibuso users, you probably know about all of these resources already. So thank you very much for listening. Now let me listen to you. Are there any questions about? Yeah. Okay, so the question was, can we use .NET Interop to access SQL Server? Did I understand it correct?
And use context connection as
context.
Context.
I'm not sure I understand, but yes, you can. If there is something you can do from .NET, I'm not sure about the context stuff. Maybe it's some class that I'm not aware of.
If you if you make an assembly that can be attached to a SQL Server, you can use the connection that the assembly has been called in to make new SQL connections.
I would say yes, but I would have to see the specific scenario to be able to answer to you. Like, is this? Are you trying to tap into the same connection that you already have?
Yes.
No,
so we can
probably not. I'm not aware of a way to like tap into existing connection to SQL Server that you already have from NAV, but you can establish a new one. And there is also a couple of nice examples in Waldo's blog, and I think also in Microsoft team blog. I'm not sure about Microsoft, but Waldo does have. Yeah. Okay. Sorry. Yes, I have 4 shirts here, but I'm giving them only for smart questions. So this was a smart question, but make sure other guys ask smart questions too. Okay, here we go. Is there anything else? Come. Yeah, okay. I would have given you the shirt, but I'm not sure if it's going to be a smart question. Here first.
I don't know if this is a smart question.
Okay.
I'm wondering why events can't be handled. We have a lot of integration stuff working with Word and Excel that are dependent on events, and we can't run these events from the RTC. We can run them from the Classic, but we can't run them from the RTC. Why is this?
Okay, there is a way to handle events actually. The thing is that you can only handle them from .NET code. So may I ask you to pass this shirt all over that way? This is a fantastic question, actually. So first, it's 2 parts of the answer. First, events in automation have been a feature of NAV. So whenever you have automation, you say like you want it with events, it would automatically create event handler methods, functions in your code unit or object, wherever you use that. So this was a feature of how automation was handled. So that feature, for some reason, and don't ask me why, was not implemented with .NET. There are probably some very good reasons for that, and I'm not aware of them. But maybe Microsoft definitely knows about that, and they can help you with that. There are a lot of people from Microsoft here who can exactly tell you why this has not been done. However, you can still create an event handler in your .NET side, like have your class library, and assign an event to a code or a function in that library, in that assembly, and that event would fire. It is just that you cannot have like, when some event fires in Excel, you want certain CAL code executed. That will not work. If you can stuff that code that has to be executed upon event firing, then and it can be .NET alone and does not depend on any NAV specific context, then you can do that. Okay. Yep. Yeah, time is up. Time. There was no time to actually implement. Okay, so it's going to be a part of. Can we say it publicly? Can we say it publicly? Okay, so it's going to be a part of NAV 7. Fantastic, thank you.
I have another question here.
Mm-hmm.
You're up.
Okay.
It's about the non-static classes. You have to construct them. But then in the example where you use the type of function from the dynamic member, you didn't construct it, but you still can use the type of function. How come?
So what I did is actually I declared a static method. So if we go back and take a look at description of my method, it was sorry, it's here. So it was public static string type. So you can have static members on instantiatable classes. So you can have a non-static class which still has static methods. So you can use them without instantiating a class. However, there are a couple of caveats. It works on your classes only. It will not work on all of .NET classes, especially not on the classes in core library. Okay. But static members can be called without instantiating a class in .NET Interop, in CAL, or C# or any .NET language. So it's a possibility. You can have a non-static, like static variable in a non-static class. It will still be static, which means one instance for all, like one property, static property of a class, which will be shared among all connections. Okay. I have one more shirt. Come on. Yeah.
I'll bring the microphone there.
Make it smart.
Hope so.
Okay.
You said with the list object, the list array, not array, but the list. Is it possible to store any kind of object in there? Is it then also possible to store, for example, a record variable?
No, because this is something that will be prevented by NAV interop. So unfortunately, you cannot attach any NAV intrinsic complex type like record ref or record of form or anything to a .NET object. Okay, so this will be prevented by the .NET interop itself. And I even tried a trick like to use .NET objects exposed in Microsoft .dynamics, .nav, .service. There are a couple of those class libraries. You cannot use that. So it will not allow you. It's just going to be impossible. .NET interop will prevent that from happening. Maybe that's going to change in future. Fred, do you know about it? No. Yeah, but it just scrambles everything. You get the instance, you just get the string, nothing else. Yeah. So you would have to make some kind of wrapper for that. Can you pass the shirt? Yeah. So no more shirts, but I'm still taking questions. Yep. Yeah. I can take mine off if you want. It's ready, you know.
Hi. Right at the beginning of the demo, you showed using a third-party assembly, putting into the NAV add-ons folder. Potentially really useful if third parties are going to make that available. What dependencies do we need to look for? What do we need to get from those third parties to make that work? Is it just DLL file or?
So I'm going to show that. So the thing is that you have to deploy everything that library depends on. So for example, this Twitter library, it did depend on many. Sorry. So it did depend on like 6 other libraries, which all have to be deployed unless they are already in the global assembly cache. So you have to care of dependencies when you're using third-party libraries.
So did you just place those files in that folder, or was there
Exactly.
a registration process?
I did that manually.
Right.
So if you're deploying into add-ins, then you have to do it manually or have like another object or installer which puts it there. If it is in global assembly cache, then it's probably part of the installation, but you should not depend. You should actually, if you're using those dependencies, you should basically have your installer check if they are present in global assembly cache, and if not, then deploy them. Otherwise, it will not work.
But there was no regasm or something like that we used to have to do with some of the COM?
No.
No.
No. There was nothing else. You have to just deploy them there.
Okay.
Yeah. Yep. We'll take a couple of more questions. I'm stealing now your time from your coffee break, and I apologize for that, but I hope it was useful for you. Okay. Yep. Sure. Can we take this question? I'm asking you, man. I deserve a shirt for this question.
It's a great world, the .NET world. And for a beginner, it's hard to find through. Is there any documentation guide or getting started to find what, where? Because it's such a big world.
Yeah. Unfortunately, my answer is not going to be nice. So there is some documentation in the help file update for R2, which explains basic concepts, but only them, and not to the great level of detail. So unfortunately, you would have to take a course in .NET or a book about .NET and learn about .NET itself, and then most of it will be trial and error for the current release. Maybe the documentation will change for next version, but again, I directed you to those 3 blogs where there is a lot of stuff about .NET Interop, so you can try there. Yeah. Okay, so I'm not going to steal any more of your time. Thank you very much for the presence. Yeah, thanks. And feel free to just drop by and ask me questions. I will be available. Thank you.